Hello. I have a quick guide to RPC frameworks. But first, let me introduce myself. So, my name is Yulia. I'm from Minsk, Belarus. I work in Belarusian outsourcing company Exagile, and also I'm an open source contributor, and I maintain a few open source projects on my own. You can check them on my social networks if we can consider GitHub as a social network. And straight to the point. So, what is RPC? RPC is a remote procedure call. It is a protocol that one program can use to request a service from another program located on another computer on a network without having to understand the network details. It's mostly used for system-to-system communication. The term is not new at all. Actually, the idea first was described somewhere in the 60s, and RPCs are widely used within distributed systems programming. And only recently, it started to gain more and more popularity among web developers community. I guess it's connected with the rise of popularity of microservices systems, because RPC helps to solve problem of system-to-system communication. At this point, we can realize what is RPC framework. So obviously, this is a set of tools and libraries that a developer can use to create RPC-based communication solution. What is important to understand about RPC frameworks is that it is usually a collection of technologies and not a monolithic singular framework. So you can choose a technology for encoding, you can choose transport depending on your RPC framework. In 2019, there are quite a lot of frameworks such as gRPC, Twirp, Thrift, Cap and Proto, Apache Avro, and I'll try to make a quick overview of each of them. But actually, I have a production experience only with one of them, with gRPC, so I'll be focusing more on this one. And the rest I'll just compare with this one based on their pluses or minuses. So gRPC. gRPC is a framework developed by Google. It is implying protocol buffer-based services definition, and it automatically generates server and client stubs. It involves bidirectional streaming and HTTP2-based transport. And first, I want to describe an example. So, in the last year, I was involved in upgrade of internal RESTful JSON system to RPC-based system. So here, how it look like. It's really a simplified image of the system, because in real life, it consists of more than 50 services. But here, just like a basic idea. So we had an AWS Lambda service, which generated events and sent HTTP request to our entry point to managing service. And this managing service sent HTTP JSON request to our other services. And once processing was done in titles or packages service, they sent events to NATS streaming service. And this managing service, it's subscribed to some topics on NATS, and it was somehow working for us. And at some point, we decided we need to migrate. You might want to ask why? What's wrong with this one? We faced a few issues of NATS. So the first one is, even with moderate load, by the way, this system, it wasn't even in production at this point, and we generated about 300 events per day. But even with this kind of moderate load, NATS already started to behave weirdly. So it encountered heartbeat timeouts. Also, some of NATS subscriptions stopped receiving messages suddenly. And those issues were enough for us to make a decision to migrate to another way to communicate between the services. So we were researching multiple options, such as Kafka, Rabbit, SQS, SNS, Kinesis, or different RPC frameworks. And the final choice was ActiveMQ backend with gRPC as a communication mechanism. We made this choice, well, you need to understand how our kind of corporation works in this way. By the way, I'm an outsourced developer, so I can't kind of affect on the choices. And the company I'm working for, it consists from several departments. One of them is DevOps department. And those DevOps guys, they already had some experience with Golang. They were writing Docker containers and so on. So they were interested into trying gRPC to write gRPC server in Golang. And by this way, maybe hire new people to their department and, well, gain new experience. And that was the main reason why they kind of insist on choosing this specific way of solving our task. And this is how our kind of final system looks like right now. So in the middle of everything, there is a new RPC server, and all other services are connected. We they kind of hold persistent connection between RPC clients, which we added to each of the services, and also there is this messaging queue. So yeah, this is how it looks. And the main profit which we received off of it is that message size now really small, and we ended up keeping our costs down because the traffic lowered it down. Another profit is shareable schema definitions, so it kind of simplifies the support of the system, because right now you can't just change something on the server and like broke all clients, because they have the same schema and you must update gradually. Or maybe the best way from the beginning, create such schema that can be extended without breaking changes. And login, well, this is kind of specific because we created custom login and we can now easily debug the system and easily find out, for example, if some messages and some subscriptions weren't delivered due to clients or due to server. And compared to NATS, for example, when it was kind of painful to find out why some heartbeats stopped to arrive, or maybe when some subscriptions suddenly stopped to work. And for us, it was like a solution that we looked for. And after we did everything, well, the system works fine for us. It solves our issues, but a tiny bit, there was a feeling that we were recreating the wheel, because, well, there's already Kafka. It exists and it solves the same issues. But we decided the Kafka is hard to configure, it's hard to manage, and it's kind of fun to try new technologies and gain new experience. So yeah, continuing back into gRPC, it has multiple implementations, blessed for Java, Golang, Python, and C++, and the rest are C#, Dart, Node.js, WebJS, Objective-C, PHP, and finally Ruby. Blessed for means that all security updates or maybe new versions or anything first will be arrived to these 4 technologies, and the rest might be waiting for a bit longer. For example, once we were upgrading our system from Ruby 2.4 to Ruby 2.5, we were waiting maybe for 2 weeks while they released the upgrade to their gem. So it supported Ruby 2.5 as well. And a quick note about WebJS. This means a client for browser. I previously told that RPC framework implies usage of different technologies, and for transport, it provides the next options. So the first one and the default one is HTTP2, except for WebJS client, because WebJS supposed to be run in the browser, and HTTP2 framework isn't directly exposed by browsers. The next one is CrowNet. It's a Chromium network stack made available for Android apps as a library. And the last one is in process. You can use it when in the same process you want to start the server and the client, and you can send the messages directly without encoding. And those are the gRPC protocols. Those are the tools that help you to encode and to decode the messages. So the default one is Protobuffers, next one flat buffers, Cap and Proto, Thrift, Avro, JSON, and RubyC. Let's dig into more details into Protobuffers. Because, for example, me, I was pretty interested into how does it work, why does it compresses the data so much compared to JSON. This is a Proto file example, so you need to define your messages and the service with method signature. So in this example, the service support 2 messages, like hello, and the method consume, which returns and accepts these types of messages. And within a message, you can see that it can contain like this field type, then field name. Oh, sorry. Field name and the unique field identifier, unique numeric identifier. And within the message, this identifier should be unique. Because deep inside, Protobuf uses, it does not operate by names, but rather by these unique messages identifiers. Seems like my clicker stopped to work. Okay. Now let's take a look on the Wireshark snapshot. So here is just a regular HTTP JSON request example. So you can see that it sends HTTP GET request and then receives the response. And the content is hello world. Here at the bottom, you can see it. And the file data, overall file data, is 25 bytes. Now let's take a look on the same message, but in gRPC and Protobuf. So the message length is 13 bytes, but it makes many requests like settings, pings, and so on. So for your specific service, it makes sense to use gRPC if you send a lot of messages and they are big. Because if you rarely send just a little message, it maybe doesn't make sense to use gRPC for your specific scenario. So yeah, and really quick overview how exactly it encodes and decodes messages. You won't use it as in your daily work, but just as an engineer to have like a basic idea on what happens inside within this black box. It might be interesting to just understand and realize. So let's imagine that we have this message hello request with a single field content of type string, and we want to send content with hey. In the result, we will receive this byte sequence from 5 bytes. Or the same sequence, but in binary representation. At this point, we need to understand that Protobuf uses different encoding and decoding depending on the data type. And in our case, this is string data types or length delimited, and the number 2 within a gRPC table. So the first byte in the stream always contains a wire type key and the field ID. First, we need to drop the most significant bit. This is the first one. So basically, what's the idea? If the first most significant bit within a byte is 1, it means that you need to continue reading the byte stream. And in case if it is 0, it means that this is the last byte in sequence, and you can stop reading your sequence. In our case, this is 0 from the beginning, so this is a complete message with wire type. And within this message, we can find out that the last 3 bits, this is wire types, and the rest is the unique message identifier. So 2 is the wire type, length delimited string, and the field number is 1. The second byte of the length delimited type is the length itself. So 3 in our case, the amount of bytes to read. And the last 3 bytes is this UTF-8 encoded value, hey. Oh yeah, we received it. And due to protobuffers, there is no need to do it manually, because Protobuf comes with Proto compiler, which, based on this Proto file, generates source code for to encode and decode your messages automatically to these byte streams. For Ruby, this is this gRPC tools gem. So you just point it to your Protobuf file, and it will generate encoder and decoders. As a gRPC pros, I can name great documentation, big community. It supports HTTP2, and the killer feature is full duplex communication between server and client. And at the moment, this is a single RPC framework which supports full duplex communication. And as a cons, there are quite a lot of issues currently on GitHub. Yeah. And I forgot to add another slide, but one more cons is gRPC, as it works with HTTP2 protocol. It might not work well with some load balancers, because not all load balancers at the moment support HTTP2, and it might be an issue for some projects. And the next one is Twirp, which we will compare. It's based on the gRPC, so the idea is pretty much the same. It also uses Protobuf, and yeah, it's super similar to gRPC. Implementations are next. It supports Ruby. Twirp framework doesn't provide really a lot of encoding and transport options, so it's basically only HTTP and Protobuf. And the main idea within creation this Twirp framework is to support HTTP protocol, because gRPC supports only HTTP2, and the guys at Twitch, at some point, they decided that they would like to use gRPC, but they can't because of their load balancers. So they came up with Twirp. So it's basically the same, but without full duplex communication. So in all articles that I found about Twirp, it is named like a better gRPC, but this kind of marketing articles, so probably we need to doubt what they are saying. Next one, simple. It also draws from those articles, because, well, I can say this Twirp is simple because it's, well, it's just the same as gRPC. And the last one is support for HTTP 1. Yeah, cons, no full duplex streams. Next one is Apache Thrift. And this one is the most old RPC framework on the market. So, and probably this is the one most widely used, especially by some old big systems. And the legend behind Thrift says that at some point there was a Google intern that didn't finish their internship at Google and started internship at Facebook. And this intern, he was working, he or she, this story doesn't tell, was working on gRPC. So he stole the idea and came with absolutely the same styled code to Facebook. So Twirp is, oh, sorry, Thrift is really super similar to gRPC, but with the difference that Facebook kinda was smart about it, and they made it open source much earlier, like maybe about 8 years earlier than Google made gRPC public. Also, Thrift has really a lot of implementations. It's widely supported among different technologies. So maybe if you're working with service consistent of a lot of microservices written in different technologies, it might be the best choice for you. Also, Thrift comes with its own transport, like they created their own custom specific Thrift protocols, like tsocket, tframed, and so on. And the same for encoding and decoding. Also, Thrift comes with totally custom options. Thrift file example is pretty similar to Proto file, but with like a new feature. It allows to use namespaces, and within namespaces you can repeat the same message types, but maybe with different content. But also within, basically struct is the same as message in the Proto files. Also at the bottom of the file there's service definitions, and it's super similar to the Proto file. Thrift also comes with a compiler which generates fully functional client and server stubs that implement the interface described in Thrift file. For Thrift pros, I can name wide languages support, and also I'm not sure if we can consider it as a pro, but currently Facebook works on the new version, and hopefully soon enough we will get a new, more performant, more effective Thrift framework. For cons, I can name poor documentation. Well, it's kind of weird because Thrift is so old framework, but it still doesn't have like fine documents, and they are quite tricky to understand. They use different technology, different terminology, I would say, and it's quite hard to figure out which kind of encoding or decoding protocol will suit best for you, and so on. Here I created a few code samples with named frameworks, so you can take a look on them. Next one is Cap and Proto. A few years ago, it kind of blew up the internet because it was named like insanely fast data interchange format and capacity-based RPC system. Also, the guy who worked at Google at some point quit it, and based on gRPC, he created a new, better protocol, and he named it new, better framework. Sorry, and he named it Cap and Proto. So this is the image from their side. So they're saying that this is infinity times faster because it doesn't spend time on the encoding. But we need to understand that encoding and serialization is not the same thing. So they are still doing the serialization, but they do not apply some tricky hacks to kind of encode the data, but they still can't send the data as it is. So they need to convert it somehow to string and to add some delimiters, offsets, and other stuff so it may be packed and unpacked. Cap and Proto have some implementation, this set of implementations. Some of them involve serialization and RPC, and some only serialization. And for Ruby, at least the official site points only to the serialization library. But yeah, the latest update was 6 years ago, and it doesn't work with the latest Ruby versions. But by the way, there are a pull request to this library with implementation of the RPC client and server itself. But it's also 3 years old by now, and so, well, at least Ruby libraries seems completely abandoned for Cap and Proto. Yeah, so we finished up with totally similar RPC frameworks, which are basically all the same. They work in the same way. Yeah, there are 5 minutes. And now, really quick, we will take a look on the frameworks which are a bit different. So, Finagle, this is transport agnostic RPC system for JVM. It supports Mux, Thrift, MySQL. It means that you can implement client, for example, directly within your MySQL database and send some messages directly to your database. And HTTP. Finagle widely used features. They are somewhat similar concept to JS promises, or maybe to Ruby fibers, if you want to compare it with Ruby. And in theory, it should work with all JVM-based languages, such as Scala, Java, Kotlin, and JRuby. I tried to find a JRuby implementation, but seems like no one interested. Or on the other hand, there is a possibility that, in JRuby, well, at least as far as I know, there are some issues with asynchronous programming with fibers in particular. So there is a high chance that it just won't work with this one. Next one is Dubo. This is currently incubating, but it's promised to be a big thing once it will be done. It's sponsored by Chinese corporation Alibaba. I think someone maybe heard about it. So, yeah, right now it's not ready for usage, but everyone kind of talk about Dubo. This involves a really complicated concept, and as I don't have a lot of time, I can't dig into the details. But the main idea is that there are a lot of abstractions behind this, and which Dubo comes with its own UI interface with some registers, monitors, some logging containers, where you can, in the real time, watch on your RPC messages that you send between your services. Well, it comes with its own Dubo protocol, also supports the listed ones. Implementations at this point is Java, Golang, Python, only client, Node.js, and PHP. And, well, I've heard that Ruby is coming, but at this point, there are no Ruby clients, so maybe someone from you can create client and server. Next one is Apache Avro. So yeah, really quick, we'll make a review of this one. So yeah, this is developed within Hadoop project. Compared to all previous RPC frameworks, it comes with dynamic typing, and all schemas are defined in JSON. So basically it means if you want to send really big amounts of data within your RPCs, probably this will be the best choice for you. It also has Ruby implementation. When it comes to benchmarks, it's really hard to tell because each RPC framework comes with some options for encoding, decoding, serialization, transport, and depending on your specific data, or maybe on your choice of these technologies within one RPC frameworks, can be totally different benchmark results for the same frame, even within the same framework, depending on your choice of encoding and so on. So it doesn't really make sense to compare. Yeah, and the last thing that I want to mention within this talk, that even before it was mainstream, there was distributed Ruby, which allows multiple Ruby processes to talk to each other over the network. And you can directly call methods from one Ruby process. You can call some, I don't know, method on some object in a completely different Ruby process. This is used, this is not abundant. It is used within Red Hat, as far as I know. Also, in the last Rails, there is such thing as parallel tests. In the Rails 6, it also uses distributed Ruby. So this thing is quite alive. And in case if you have several services, for example, several Ruby on Rails services, it might be a nice choice for you. And that's it. Thank you.